Deep in northern Tanzania, near the border with Kenya and nestled within the Great Rift Valley, lies one of Earth's most surreal landscapes, Lake Natron, a blood-red alkaline lake that both sustains life and terrorizes it. Here, between scorching mudflats and the looming presence of volcanic peaks, lies a place where chemistry and geology merge to form a world that seems more alien than earthly. A place that has inspired tales of petrification, massive flamingo nurseries, and ecological paradoxes that challenge how we think about life itself. We dives into the science, the chemistry, the myths, and the ecology of Lake Natron, a place that might be beautiful from space, yet deadly up close. The red mirror of natural extremes. From above, Lake Natron appears like a giant crimson mirror, a vast sea of reds, pinks, and oranges shimmering under the African sun. Its surface reflects the sky and surrounding peaks like a living painting. But the color itself comes from life, not from the water. The lake's alkaline brine feeds blooms of pigment-producing microorganisms such as cyanobacteria and haloarchaea, whose salt-loving cells tint the water in dramatic hues, visible even from satellite images. This peculiar palette is more than aesthetic, it's a clue to the lake's extreme chemistry. Lake Natron has no outlet. It is an endorheic basin, so water leaves only through evaporation, leaving behind a growing concentration of dissolved minerals. Chief among them is natron, a mixture of sodium carbonate and bicarbonate, along with trona and other alkali salts, which drive the lake's pH skyward. At times, the water can reach a pH above 12, many times more alkaline than seawater and almost as caustic as household bleach. This extraordinary alkalinity has shaped Lake Natron into one of the most hostile aquatic environments on Earth, yet also one of the most ecologically pivotal. A chemical killing field, not a magic stone turner. Stories and striking photos have made Lake Natron infamous worldwide, with sensational claims that it turns animals into stone. While the poetic image is powerful, the truth is grounded in chemistry and biology rather than magic. What happens is this. Lake Natron's water is so highly alkaline and mineral-rich, if an animal, bird, bat, or mammal dies in or near the water, its soft tissues can dry out and mineralize rather than decay rapidly. The high concentrations of sodium carbonate and other salts can cause a form of calcification where mineral deposits bind to the tissues and harden them over time, creating a preserved, statue-like appearance. This process is not instantaneous. Animals do not instantly become stone upon touching the lake. Instead, the water's caustic, pH, and salinity can injure or kill sensitive animals over time. Once dead in that environment, normal decomposition halts and minerals can embed in the tissue. The result is a calcified carcass that resists decay, giving the eerie impression of petrification. Photographer Nick Brandt's haunting images of calcified birds and bats captured along the shores brought global attention to this phenomenon precisely because of the striking juxtaposition, lifelike forms preserved in death. But scientific analysis makes clear that these are mummified carcasses, not literal stone transformations. This distinction matters, but the dramatic visuals help explain why Lake Natron is sometimes called the Medusa of the natural world, a place where life and death are frozen into visual poetry. Why the water is deadly, Geochemistry and the Rift Valley. To understand Lake Natron's lethal chemistry, we must consider where it sits. The East African Rift System, an active tectonic zone where Earth's crust is pulling apart. This rifting permits mineral-rich springs, particularly those fed by volcanic activity, to discharge into the lake. For Lake Natron, one nearby volcano of note is Old Doinyo Lengai, known locally as the Mountain of God. Unlike most volcanoes, Old Doinyo Lengai produces natrocarbonatite lava, which is rich in sodium and carbonate minerals. As this material weathers and dissolves, natron and trona salts are transported into Lake Natron, contributing to its extreme alkaline composition. Combined with the high evaporation in this arid region, the result is a hyper-alkaline soda lake with a chemical profile that very few organisms can tolerate. Water temperatures can also climb perilously high, up to 60 degrees Celsius, 140 degrees Fahrenheit, in the shallow areas during peak heat, adding another layer of stress for any life that tries to thrive here. So the lake's petrifying reputation arises from geochemistry and environmental extremes, not myth. It's a place where ordinary biochemistry breaks down, chemistry dominates, and the usual rules of life and decay are rewritten by salts and heat. The serene feast for flamingos, living among the deadly. Paradoxically, Lake Natron is not lifeless. In fact, it is one of the most important breeding grounds on Earth for the lesser flamingo, Phoeniconias minor, a species that has adapted to the lake's extreme conditions and depends on it for survival. Every year, millions of lesser flamingos, estimates suggest around 75% of the global population, return here to breed. These birds are uniquely equipped for life on Lake Natron. Their leg scales and tough skin protect them from the caustic water. Their specialized glands can excrete excess salt. They feed primarily on cyanobacteria, especially the blue-green algae Arthrospira, often miscalled spirulina, which thrive in the lake's alkaline brine and provide both color and nutrition. The result is a spectacle unmatched anywhere else on the planet. Vast flocks of bright pink flamingos nesting on alkali flats and shallow waters, their reflections mirroring the Red Lake, a vivid symbol of life coexisting with extreme chemistry. These isolated breeding islands are so remote and caustic that potential predators cannot safely approach nests, giving chicks a rare degree of protection. It's a case where the lake's lethal reputation becomes a shield for life, enabling a delicate bird species to breed with unusual safety. Local people, sacred land, and living culture. People have long lived around the Natron Basin, pastoral Maasai and other communities who move livestock across seasonal pastures and drink from springs where water is safe. For them, the lake is part of a living landscape, a source of salt trade, grazing, and stories. Local oral traditions weave the lake into rites, taboos, and place names. The flamingos are not just a spectacle, they are part of seasonal rhythms that have governed grazing patterns and spiritual life for generations. That human presence complicates conservation, but it also offers solutions. Community-based management, recognizing local land rights and building eco-livelihoods is often the most durable path to protect places like Natron. If the people who live by the lake benefit from flamingo tourism, from sustainable salt harvesting, and from water stewardship, they become stewards rather than spectators. The future of Natron depends on aligning ecology with economics and culture in ways that respect local rights. Picture the shoreline at sunset, a bank of pink flamingos hunched in the shallow red light, their bodies mirrored on the glassy alkaline surface. Behind them, Oldoinho Lengai's silhouette softens into volcanic blue. In the shallows, a bird's carcass crystallizes slowly into salt, a mute testament that life here is perilous and precious. Lake Natron forces us to look at extremes and ask what we value. Do we protect the strange and fragile, or do we monetize it until only photos remain? The answer will shape not only a lake, but how we measure stewardship across the planet's most unusual places. If you want to keep exploring Earth's strangest places and learn what their survival tells us about our own, subscribe to Discovering the Unknown. We'll bring you the science, the stories, and the solutions that matter, because some landscapes are more than scenery. They're warnings, archives, and teachers.